Welcome back. This is Mr. Greenstein Geometry, and we're talking about section 9.6, solving right triangles. We're talking about the inverse function of the trigonometric functions. So, solving another triangle. So we're going to try this one, and in solving this one, we don't have as much information as we did on the other problem. So we're missing two of the sides. To get these sides, we're going to have to use this angle and this side, which is the hypotenuse. Since we have the hypotenuse, that means that we're going to use either the cosine or the sine function to be able to get that. So if I was to write this down, to get G, that is the adjacent side to the 25 degrees. So adjacent means I'm going to use the cosine. So I'll use cosine of 25 degrees is equal to the adjacent over the hypotenuse, which is G over 13. And when you work that out, then G turns out to be 11.78 approximately. Then to come up with H, we're going to be using the Pythagorean theorem down here. So all I have to do is just plug in the G squared plus H squared equals 13 squared. And then I come up with what H is. And H is going to be approximately 5.49 after you work out that equation. To find angle G, that's not hard, because all we have to do is say we have the complement of 25, so 90 minus 25, and that's going to give us 65 degrees. So that's how we compute all the different angle and length measures of this right triangle. Now let's look at a real-world problem. Let's say that we're in theater and we're creating this raked stage. So a raked stage is a stage that slants towards the front of the stage. And in this particular case, I have something that is going to be 30 feet on the hypotenuse, and I have 2 feet going up here, but I want to find out what this angle is here. To do that, I'm going to be using this side and this side. Well, that means opposite over hypotenuse. Opposite over hypotenuse is sine, so we're going to use the sine of x is equal to the opposite, which is 2, divided by the hypotenuse, which is 30. And then we take the inverse sine of each one of those sides. So we have the inverse sine of 2 over 30. And if I do that, I come up with an angle, and the angle is 3.82 approximately. To be safe, we have to be 5 degrees or less, and we are less than 5 degrees. So this is a safe stage. Now let's take a look at another real-world problem, and this is the London Eye, which is this huge Ferris wheel across from the Parliament building in London. It's amazingly big, and I've been on this thing myself. It's really impressive. So the problem states that we have a radius of 67.5 meters, and it takes 30 minutes to make a complete rotation. So we're going to start the car at 67.5, 0 on a coordinate plane. What is the car's location after 6 minutes? So let's take a look at this, and we're going to use a graph to come up with a solution to this. So if it makes one revolution in 30 minutes, then how long of a revolution does it take to go 6 minutes? Well, we know that for 30 minutes, it goes 360 degrees. If it goes 6 minutes, so that's 6 divided by 30 minutes, it's the same thing as x degrees over 360 degrees. And if you work out x, it turns out to be exactly 72 degrees. So let's just pretend that this is the starting place, and this is going to be 67.5, comma, 0. And then at some point, the car is going to rotate up and be 72 degrees. So this is going to be 72 degrees. And we want to find out what this location is right here. So if I draw a vertical and then a horizontal, those are the two things that I want to find out. I want to find out what this x value is and what this y value is. The thing about the hypotenuse is the hypotenuse is always going to be 67.5. And that's because the distance from the center is always going to be the same. So this center out to this point here is always going to be 67.5. So now we have the angle of 72 degrees. We have the distance, 67.5, and I want to find what x is. X is the adjacent with the 72 degrees, so that means I'm going to use cosine. Cosine of 72 degrees is equal to x over 67.5. And when we calculate x out, we're going to get an x that's going to equal 20.86 meters. Next thing we want to find is the y. The y component is just a matter of saying, well, that's the opposite the 72 degrees, so we're going to use the sine. So sine of 72 degrees is equal to y over 67.5. And when you calculate this out, you will get a y that equals 64.2 meters. So our new location up here is going to be 20.86, comma, 64.2. And that's how you would solve this problem. We'll go over problems like this and others in class the next day.